Hi, welcome to my channel, JaberTime. Today we're going to go over the greatest common divisor, the least common multiple, and the relation between them. We're going to go over three things and, of course, some examples. When we look for the greatest common divisor and the least common multiple, we're going to look at the factors and the multiples. That's one idea. The second idea is using the prime factorization of A and B. And the third thing that we're going to talk about is when the greatest common divisor and the least common multiple, if you multiply them, when this is true, that it ends up the same as AB. So one way to do it, or one way to use this, is imagine if you have the least common multiple of A and B. To find the greatest common divisor, you could multiply A times B and divide that by the least common multiple. You'll get the greatest common divisor. So that's one benefit for it, but it doesn't work all the time, and we're going to show you how. Let's get into it. Let A and B be whole numbers, not both zero, because it doesn't make any sense to have both zero and look for the greatest common multiple and the greatest common divisor and the least common multiple. The greatest natural number D that divides both A and B is called the greatest common divisor. And we write D equals GCD, greatest common divisor of A and B, which is also called the greatest common factor. The greatest common divisor from prime factorizations. Let A and B be natural numbers. Then the greatest common divisor is the product of the prime powers and the prime power factorizations of A and B that have the smaller exponents, including 0. We're going to see that in a few examples. So as an advice, keep in mind when you look for divisors or factors, you're going to go for less. Because sometimes for some reason we ask for the greatest common divisor and we get back from students the least common multiple. For divisors it should be less than, not more than. A quick example as an overview: 12 and 30. Those are my A and B. Factors of 12 will be 1, 2, 3, 4, 6, 12. Notice that 12 divides by 12 divides by 6, 12 divides by 4, 12 divides by 3, 12 divides by 2, 12 divides by 1, of course. Those are the divisors or the factors. For 30, we are going 1, 2, 3, 5, 6, 10, 15, and 30. Notice that those are underlined. Those are the common factors, but 6 is the greatest common factor, and that's why we call it the greatest common factor. So the greatest common factor of 12 and 30 is 6. And here's the prime factorization. To get the prime factorization, you need to use maybe the tree diagram. That's one option. 12 divided by 2, you get 6. 6 divided by 2, you get 3. We circle the end of the tree diagram right here, and we end up 2 and 2 and 3. 2 times 2 times 3. 2 2s and 1 3. We do the same for 30. So it's 2 times 3 times 5. You could double check. That's 15. 15 times 2 is 30. So if you notice, when we look at the prime factors of 12, it's 2, 2, 3. And we look at the prime factors of 30, it's 2, 3, 5. But overall, in the same problem, we're looking at 2s, 3s, and 5s. So for the 12, we have 2 to the second, 3 to the first. That's 2 2s, 3 to the first. This is 5 to the 0. Because I'm using this box, it eliminated part of the 0 here. It's a 0. There is no 5s here. This one right here, as you can see, it took some part of the 2 because of the frame. It's 1 2 as factors, I mean 1 3 and 1 5. So when you go for less and using the smaller exponents right here, we're looking at between the 2's 1 2, between the 3's they're both the same, so we're gonna pick 1. For 5 to the power 0, just keep that in mind, this is 5 to the power 0, and 5 to the power 1, we're gonna take 5 to the power 0, which is 1. So basically we are taking 1 2 for the 3 1 3 as factors. When I say 1 3, I don't mean like 1 times 3. And for the 5 to the power 0 and 5 to the power 1, we're gonna take 5 to the power 0, of course the 1 less, it says right here, we're gonna is the product of the prime powers. This is a product of prime powers in the prime power factorization of A and B that have smaller exponents. So we're looking at 5 to the power 0, 5 to the power 1, the smaller exponent is 0, so we're going to take the power 5 to the power 0. 2 to the second, 2 to the first, this has a smaller exponent, so we take 2 to the power 1, which is 2 times 3, and 5 to the power 0 is 1. Anything raised to the power 0 is 1. 2 times 3 times 1 is 6. As you can see, it does agree. It's the same answer. So when do you use this? Well, if you have larger numbers, you don't want to look for the factors this way. Imagine if I give you 5022. You don't want to write all the factors of 522 and 732 and so on, and start looking for which one is the greatest common in between them. So the prime factorization is a quicker way. Least common multiple, same concept. I'll read it a little bit slow, but we're going to see some examples. We're going to use the same example for now as introduction to the lecture. Then we'll jump to the examples. Least common multiple. Using the prime power factorizations. Let A and B be natural numbers, then the LCM, the least common multiple of A and B, is the product of the prime powers and the prime power factorizations of A and B that have the larger exponents. What did we say about divisors? Go for less. And what do we say about multiples? Go for more. I think that should help from now on. Going back to 12 and 30. And I want to see the prime power product of each with colors clearly. This time I used a different style. It did not cut part of the 0, as you could see. And right here is for the 30. We did the greatest common divisor. That's going to go right here. And the least common multiple is going to go here on one page. But here's a bonus. Listing multiples, sometimes it takes also time. To list the multiples of, let's say, 12 and 30, you're going to multiply 30 times 2, which is 60, another 30, that's 30 times 3 times 30, which is 90, and then 120, and so on. That's kind of a little bit quick, but 12 will slow down sometimes, right? 12, 24, and 36, 48, what comes after 48, 60, and so on. Here's the bonus. One way to do the multiples, you could just use Excel. In Excel, I have something here. If you need help with Excel, let me know down below and I'll get back to you. Let me know what's your question so I could direct that to your question. I use Excel for a lot of different things. One of them is grading. My grade program is just Excel. Here's an Excel. Multiples of 20 will be 12, 12, 24, 36, 48, 60, 72, 48, and the rest continues. Multiples of 30. I'm not going to read them. You could see them. But look at 60. I used color here to show you that it's a common multiple. And I used a different color to show you that 120 is a common multiple. But we want the least common multiple. So 60 is the answer. Now, how do you use that in Excel? I did not type those, taking them from a calculator. All what I did is the following. Take a look. I typed 12 and 24 and I highlighted those two circles by dragging my mouse. I got close to this corner. When you get close to this corner, holding the mouse, it's going to change it to a plus and darker sign, like bold plus symbol. While it's bold plus symbol, drag it and go down, slide down. Excel is gonna know or think that you need multiples, because to go from 12 to 24, you are not adding 12, let's say. You're multiplying by 2. And if you want Excel to do it correctly, that we're not adding, we are multiplying. So you could do 12, 24, 36 and highlight those 3 cells and go down. Give it a try, you're gonna like it. Try it for 30 and 60 and you're gonna see the following. Then you could compare and look at a common one. That's one thing on the side. Now let's go back to the topic and use my notes and examples. Here's, I displayed them at the same time because I want to speed up the process. It's a little bit over 10 minutes now, and the video is going to go up to 30 minutes max. I'll do my best not to go over 30 minutes. So when you look for the greatest common divisor, we go for less. I'm not reading the whole thing from the previous slide, but let's go for less, looking at the 2s, 3s, and 5s. 2 to the second, 2 to the first, we go for 2 to the first. 3 to the first, 3 to the first, we'll go for 1, 3. 5 to the 0, 5 to the first, we'll go for less, which is 5 to the 0. Doing the math, that's 2 times 3 times 1, which is 6. Let's go for more. Least common multiple. 2 to the second, 2 to the first, we're going to take 2 to the second. 3 to the first, 3 to the first, we're going to take 3 to the first. They're both equal. And between the 5s, we're going to take 5. Not 5 to the 0. We're going to take the higher, which is 5 to the first. Do the math, and that's 4 times 3 times 5, which is 60. As the table in Excel shows. Now, as I said, when you use keywords, when you use concepts of understanding what the formulas tell you to do, you'll understand more and it sticks with you and stays with you and it helps you more with topics. Here's a quick slide. I have everything displayed because I don't wanna slow down, let's say, doing it. Hopefully that benefits you to see an idea. Here's 14 and 20. Looking at 14 and 20 as prime factorization product. Multiples will go for more. The LCM go for more 2s and more 5s and more 7s. Now 140 divided by 14 and 140 divided by 20. Check. We could see that. Using the prime power factorization, that means it divides by 14 and it divides by 20, but I'm using the prime powers. But take a look. Why it has a 5? Because when you go here, it has to divide by 5. Why it has a 7? Because on the left side, it has to divide by 7. Why 2 to the first, 2 to the second? Why we picked 2 to the second in our answer? Well, this divides, looking at the 2's, yeah, that's a 4 divided by 2, which is 2. But this is 4 divided by 4. So in order to divide by both, looking at the 2's, you need 2 2's. You need the 4. Hopefully that helps. Now looking at the divisors, the greatest common divisor is 2, by going for less exponents, alright? 14 divides by 2 and 20 divides by 2, check, yes. Looking at it as prime powers, look, I have to have the 2 to divide by 2. I can't have the 5 here. It doesn't work. I could have the 7, but the 7 does not work here. So the 7 works for 1 and the 5 works for 1, but it doesn't work for both. We need a common factor. I think we all agree now that 2 is a common factor. 5 is not a common factor. Hopefully my example is clear. Why we pick less for factors, we pick more for multiples. Here's my third idea listed on the front slide. A times B is equal to the product of the greatest common divisor of A and B and the least common multiple of A and B. So you want to keep this in mind. We're going to use it as we go on. Now let's get into the examples. 150 and 60. Prime factorization of A. You know how to do it. I'm using colors. I just want to take less out of your time and display more examples. All these examples will be displayed below with timestamps. So you could jump to any example. You could revisit instead of watching the whole video again if you need it. Now, looking at multiples, we're going to go for higher or more and more and more of each factor. You could see that for the 3's, and for the 5's we're going to go for more. Multiplying, doing the math. I did the math on the side. I'm not grabbing my calculator now. Want to save some time. I have 300. Let's go for GCD for less. Looking at the 2's, looking at the 3's, looking at the 5's. We're gonna take less 2's. We're gonna take less 3's, but we have no choice. It's only 1 3. We're gonna take less 5's, and doing the math, that's 30. Multiplying A times B on the left, multiplying LCM times GCD on the right, same answer. So as you can see, this is my style. Hopefully you like it. Every YouTuber has his own way. I picked up this way because I want to save you some time and deliver and show you more examples. Hopefully you like it. If you do like it, consider give it a like, and let's move on. And subscribe if you have not done so yet. Thank you for your support. Thank you. Here's more examples. 2 and 5. If you take your time and do the multiples of 2. If you take your time and do the multiples of 5, I could see what's in common. If you do the prime factorization of 2, it's only 2, which is a prime. If you do the prime factorization of 5, which is only 5, that's pretty much it. But because on the table we have 2's and 5's, we're going to do that differently right here. We're going to write 2 to the first and 5 to the power 0. Down here, we're going to write 2 to the 0 and 5 to the first. So could both and look for more and less when you look at prime factorization. Now, from the multiples right here, the least common multiple is 10. The divisors or the factors of 2 divides only by 1 and by itself. For the 5, looking at factors or divisors, it only divides by 5 itself and 1. Now, looking from the divisors, the greatest common divisor between the last here and the last here is just 1. From the prime factorization, we're going to go for more 2's and more 5's. We're going to go for less 2's and less 5's. More 2's, more 5's, less 2's, less 5. That means you're not going to take anything right here, which is 1. Okay, now let's double check. 2 times 5, 10. LCM times GCD, 10 times 1, 10. Works. Next, 2 and 6. I'll go a little bit faster now because you got the idea. And I'm saving you some time by writing everything right here ahead of time. Multiples of 2, multiples of 6. We could see the common one. 6. Divisors of 2, divisors of 6, or factors of 6, 1, 2, 3, and 6. The greatest common divisor or factor between them, the greatest one is 2. Looking at the primes, prime power factorization, that's a 2. I displayed the 3 because the 3 is going to show up in the 6. Looking for more, looking for less. I jumped here because I was just trying to go a little bit fast. less 2's. I have 2 to the first, so I'm gonna pick 2. 3 to the 0, 3 to the first, I'm gonna pick 3 to the power 0, and that's a 2. A times B, LCM times GCD, 6 times 2, same answer. Another example, 8 and 20. 2 times 2 times 2 is 8, right? There is no 5's because this has a 5. I displayed 5 to the power 0. And 4 times 5 is 20. Or 2 times 2 times 5 is 20. LCM, go for more 2's, more 5's. GCD, go for less 2's and less 5's. We're going to pick 2 2's and 0 5's. A times B, and multiply these, you get 160, same answer. Good. 8 and 14. I displayed it as 7 because it shows in this 14th. Go for more. Go for less. Check. Same answer. Every time you want to slow down and see it before I jump to the second example, like you just hit the space bar and take some notes. It's gonna pause the video, and if you hit the space bar again, it's gonna play it. 14 and 20. That's 14. That's 20. Now I did not display the 5 to the power 0 or the 7 to the power 1 or 0 here. We know what we're doing now. Let's move a little bit faster. More 2's, the higher in 5's, the higher in 7's, and that's 140. Greatest common divisor, less 2's, less 5's, less 7's as exponents. And I'm saying less and more, but that's not the main way books say it. But I want to try to speed up the process, focusing on more exponents as of prime power factorization and less. Okay, let's check. 14 times 20, 280, and LCM times GCD is 280. Another example, 15 and 45. 2 times 5 times 5, 9 times 5, more 2's, more 3's, more 5's, and GCD, less 2's, less 3's, and less 5's. This does not have a 3, so we're gonna pick 3 to the power 0. Do the math. I got 1 times 1 times 5, which is 5. Multiply 50 times 45. Multiply 450 times 5. Same answer. Now, here's a homework problem. This was in the homework in our textbook, but was not given as A and B and C. It was given as the prime factorization this way. So I multiply them together, and the numbers that I have as A and B and C in standard mode are on the left. Now, because I'm speaking 3's and 2's, I could see 5's and 7's. I'm gonna display it in more detail. So this has no 2's, so I showed it. This has no 2's, and this has no 7's, as you can see. Let's go for multiple. The higher in the 2's, right there. 7's, 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 that's the higher. I'm not reading this, as you could see. There's no need. While I'm recording the video, it's gonna slow you down, and it's gonna let me speak faster. But you get the idea. Let's go for the GCM after we multiply these numbers, which is a big number. I got this number. I'm not reading it also. Now let's go for less. That's GCD, the factors. I have 7 to the power 0 because this is the lowest. Doing the math, that's easier than this right here. 75. Multiply A and B and C. It came up to be a big number on my calculator, so I am rounding right here, as you can see. This is like 6 something, So I rounded it and I wrote approximate times 10 to the power 12. Now if you multiply 75 times this number, I have this, but they are not the same. So what's happening? Earlier we talked about A times B equals the LCM times the GCD, but when I used ABC in this example, it did not work. So what's happening, we will see in a few minutes. Here's another homework problem. 12, 16, and 8. Having it as prime factorization, here's A, here's B, and here's C. Displaying them all with 2's and 3's, I have it this way. Let's go for more. The highest exponent for the 2's is 4, and the highest for the 3 is 1. Doing the math, it's 48. Going for less exponents, that's what I have, 4. Let's multiply these numbers. I have 1536. Let's multiply 48 times 4 and put it right there. 192. They're not the same. So the question is, when they're going to be the same? We're going to find out. One more example, 18, 24, and 12. A little bit faster, but you could slow down and take notes after or before I jump to the second example. Here we go. Here's the 18. Here's the 24. Here's the 12. And here's the higher of each. The 2's, the 3's, as you can see. 72, the greatest common divisor. Go for less 2's, that's the first one. Go for less 3's, so it's going to be to the first. That's a 6. Let's double check. Multiply these numbers. I have this. Multiply 72 times 6. I have 432. They're not the same. Now here's what you have been waiting for. When does it end up equal? When you have ABC. Here's my answer. They will be equal to the product of A times B times C if the greatest common divisor of A and B is the greatest common divisor of A and C, same thing as the greatest common divisor of B and C. So any way you take it, the greatest common divisor between any two numbers will be 1, meaning they are relatively prime, meaning they don't have anything in common as a factor except 1. That's the highest one that you could find. Here's a good example. 2, 3, and 5. I think we could see that the greatest common factor or divisor between 2 and 3 is 1. The greatest common divisor between 2 and 5 is 1. The greatest common divisor between 3 and 5 is 1. So this is the 2. I displayed the 3's and the 5's for you. Here's the 3's or the 3, and here's the 5. Going for the least common multiple, we're gonna take the highest from each factor. For the 2, we're gonna take 2 to the first, and let's move on. Doing the math, I have 30. Let's go for the greatest common divisor, less of each. That's 1. Going on the left, 2 times 3 times 5. That's 30. Going in the right, multiplying 30 times 1, 30. Yes, they're equal. So that's how it works. Only when 2 and 3 and 5, as an example, they are all relatively prime. Each 2 of them will be relatively prime. The greatest common factor will be 1. That's gonna work. Now this is so clear, the 2, 3, and 5, but 2, 3, and 6, no. I could see that 2 and 3 are relatively prime. The greatest common factor is 1. But when you go 2 and 6, no, they both divide by 2. The greatest common factor is 2. Between 3 and 6, the greatest common factor is 3. So they're not all relatively prime. So they don't have to be primes, but like 6 and 7, and they are relatively prime. 6 and 7. 6 is not prime, but the greatest common factor of 6 and 7 is 1. So because we know what we're talking about now, what do you think? 2 and 3 and 6. Do you think right here below, right here, is going to be equal or not? I think they're not going to be equal, because as I said, they are not relatively prime. And let's move on. Here's the 2, here's the 3, here's the 6. Let's go for LCM. And let's go for this GCD. And let's check. On the left, 2 times 3 times 6. 36. On the right, 6 times 1. They're not equal. So you want to keep that in mind. It only works when A and B are relatively prime. That's how we speak. Or the greatest common divisor is 1. When A and C, and when B and C are relatively prime. That should do it for this video. Thank you, and I'll see you next time. Thank you for watching. If you like this video, hit the like button and subscribe, and I'll see you next time. Thank you.